Okay, so today I'll be discussing about the kinematics. Okay,
Uh,
so and do you know your syllabus code? It is
and no, I have no idea.
WPH11. Okay,
Okay.
so this is going to be your physics core. Okay, and
Okay.
your specification will be from 2019 till present. Okay.
Okay.
Okay. So before that, there was an old specs. Okay, if you want to solve the question, you can, but there's something that changed after that. Okay. So in today, we are going to discuss about kinematics. Kinematics. Okay, so it's basically the part of the mechanics, the whole new or a whole big thing. Okay, under which there's a mechanics, or there's a kinematics. We are doing it on 9 of August 2025. Okay. So in kinematics, as basically kinematics has the weightage of around 12 marks to 15 marks. Okay, 12 to 15 marks.
Okay.
So um 12 to 15 marks. Okay, and it will only be tested in unit 1. Okay, fine. So in the content of this chapter, we will going to have the simple terminologies. Okay, and then we have the type of the motion. Okay, type of type of the motion, or you can say motion analysis, where we'll be going to discuss three motion. Okay, one is vertical, and then horizontal, and the third will going to be the projectile. Okay, projectile. Okay, so about the vertical and horizontal motion, you guys um I've studied something or most of the thing in your O-levels, but the projectile motion will going to be a new thing to you, and it's basically the combination of vertical and horizontal motion together. Like if you throw something, so how it fall or how it cover the path is basically the projectile motion. Okay, okay. So
Okay.
and after that, we have to understand some concepts of the graph. Okay. And then maybe in the middle of the chapter or at the end, we have to cover some of the experiments. Okay.
Okay. So the
Experiments.
exam will also like have questions on experiments.
Yes. So basically,
Okay.
in the exam, they'll give you the question where they ask you to evolve or analyze or maybe come up with an idea of how you can plan the experiment. Okay. So they gave you like 5 to 6 mark
Mm,
question where they ask you all of the things. Okay. So, and
mm,
in
okay.
kinematics chapter, we have like 2 to 3 things that we have to understand in order to understand the experimental techniques and all of this stuff. Okay. So, yeah, and they will going to be related with the kinematics. Okay, like the only kinematics. Okay, but there are some experiment with in the other chapter as well. Okay, so we'll discuss accordingly. Okay, so let's start with the terminologies first. Okay, so terminologies, terminologies. Okay, so we basically have 5 to 6 terminologies like the distance, the displacement, the speed, the velocity, time, and acceleration. Okay, so these are some terminologies that we have to discuss. Okay, so the first thing is the distance. Okay, and it is going to be the distance is going to be any route or any possible path taken by the object from one point to another point. Okay, so it is any possible route taken by the object from one to another point. Okay, and
Yeah.
it will be measured in meter. Okay, and kilometers, centimeter, decimeter, millimeter are going to be the prefixes. Okay, while it is a scalar quantity. Okay, scalar quantity means it will have only magnitude and unit, no direction. Okay, scalar quantity. Okay, then we have the displacement. Displacement, and the displacement is going to be the shortest possible distance, possible distance uh, between the 2 points, the 2 points in the specific specific direction. Okay. So these are the two things, and the unit is going to be in meters. Okay, and it is a vector quantity. Okay, please keep in mind
Yeah.
they'll ask you about the quantity in MCQ. Okay, mainly in MCQs. Okay.
Oh, okay.
Now let's say if we have, let's say, two paths. One, let's say the object starting from point O here. Okay, and it's like moving. Wait, it's like moving that way, and then takes a U-turn. Okay, and then coming back to this point. Okay, so it started from, let's say, A, take turn at O, and then end up at B. Okay, so and let's say this distance is 100. Okay, and this is the other one is, let's say, 30. So what will going to be the distance and the displacement? Just ignore the distance during the turning. Okay, let's
So
say this is 30.
distance is
Hmm.
the distance would be 130, and
Okay,
the displacement would be just 70.
good. So 130 and displacement would be 70. But for the displacement, you required certain direction. And since the object
To the
is
right.
to the right, yes. So basically, it is like if you just look at this one, so it is moving to the right, okay, or
Yeah.
it is directed to the
Yeah.
right, right? So
Oh, okay.
okay, to the right, you're eastward, okay. Basically, like to understand this, you have to make some vectors, okay? So 100 vector is in this direction, okay, and 30 vector is in that direction. So you'll be left with left with 70 vector in this direction, okay?
Mm, okay.
Okay. So fine. Now, if you have another concept where like your object is, let's say you're standing right here, okay, and let's say somebody kicked the object, you have like football or something,
Yeah.
and somebody kick it, so it falls like this, okay, and from let's say point A to point B, this is point A, let's say, and this is point B, okay.
Mm.
So okay, so if I give you the height, let's say this is going to be your 4, and this is going let's take it as 6. This is, let's say, 8. Okay. So can you
Uh,
tell me the displacement and the distance? Although the distance, you cannot tell the distance, exact distance, but you can tell the displacement.
um. So is it like
Okay, by the way,
um?
distance will going to be the path taken by the object. Okay. So, and over here
Yeah.
is not a arc of the circle, not not a circle. It's just a projectile. Okay. So to measure this thing, we actually have to measure it. Okay, but we don't have anything to measure it. So for now,
Uh,
I'm just writing dash dash. But what about the displacement? You can write the calculate the displacement as well. Calculate the displacement easily.
is it like you make it into a triangle first,
Yes, very good. And
and then
then
you can do like 6 squared plus 10 squared and root all over.
good, very good, perfect. Okay, so this is your triangle. Okay, and right. So this is your triangle, and then you can do 6 squared plus 10 squared. Okay, and holding under root, and it is going to be 36, 100, 136, 136 under root. It
Root
will going to be
34.
11 root 34
It's 2 root 34.
to root, sorry, 2 root 34. Okay, or 11 point something something, I think.
Yeah.
Same. Okay. And if you have something like, let's say you have an object moving in the circular path, okay, and started from this point, and it end up at this point, let's say, mm,
Mhm.
okay, and it's basically the like it covers the arc of the circle, okay,
Yeah.
right, come on. So it has covered the arc of the circle path, okay. So can you tell me how much distance it covered and the displacement as well? If let's say I gave you the radius as 6.
Uh, so does that mean if we calculate like the arc length?
Yes, very good.
So uh, would this be in like degrees or radians?
Um, for that you can do it in degrees,
Mm.
but
So
I just
like
want the
if
path.
uh,
You don't
um
have to use the degrees or the radians. No,
wait,
look.
so
Basically, what will you do
yeah,
over here is, this is the like the distance is going to be from this point to that point. Okay, so it is
yeah.
the circumference of the circle, And you know
Yeah.
that the actual circumference of the circle has a formula of
2
2 pi
pi
r,
r.
2 pi
Yeah.
r, but it is, since it is covering quarter of the circle, it is actually not look like so. So let me just draw it. It should be
Okay.
exactly perpendicular, and now it's looking. Okay. So now, since it is a quarter of the circle, so you can just divide the length of the circumference length by 4. So you'll be pi r, you can put 6 and divide it by 2, and then it would be 2 ones are 2 threes are 3 pi. Okay, 3 pi. Okay, so
Okay.
the distance is going to be 3 pi, this distance.
Okay.
Okay,
Okay.
and what about the displacement?
Um, mm, um, would it be a triangle again? Like,
Yes, very good, very good.
so if both of them are 6, and then it'd
Mm-hmm.
be 6 root 2.
Very good. So displacement will going to be 6 root 2. Okay. So this is distance, and displacement will going to be this distance. It will going to be this distance, and this is 6 root 2.
Yeah.
Okay. So you are saying 6. So basically 6 squared plus 6 squared and whole thing under root is equals to r is equals to displacement. So that will going to be 36 plus 36 and under root 72 mainly. Okay. So if you solve under root 72, so you'll get 6 root 2. Okay. And this
Okay.
is it. Okay. So these are some concept of the distance and displacement. Okay. And so you should know about them. Okay. Yeah, if I do. Yeah, because and very perfect. So, okay, let's move on to the speed and the velocity. So kindly keep in mind that distance can never be zero, okay? But displacement can be zero, right? If somebody is
Yeah.
starting from a point and he get back to the same point, so the displacement will going to be zero in that case, okay? So this is the main difference between the distance and the displacement, okay? So we can write distance can never be zero, can never be zero, but displacement displacement can be zero in some cases. Okay. So this is a concept. Now we have the velocity, this speed and the velocity. Okay. So speed. Okay. Can you define the speed by the way?
The amount of distance traveled in an amount of time.
Okay, perfect. Or we can say that is a rate of change of distance. Okay. I'm not using the
Okay.
word the amount of because in AS you have to be a bit precise. Okay,
Oh,
so that's why I'm using the rate, or you can say that the change in distance over the change in time. Okay, but you don't have to use
okay.
amount. Okay,
Okay.
okay. So this is the speed. If you say the unit, so unit is going to be
Meters per
meters
second.
per second. Very good, and it's a scalar quantity, no direction. Okay. And if you just write the formula, so speed or just speed S is equals to distance over time. Okay. By the way, please keep in mind we have two type of speed. One is like the instantaneous speed, and the other is like the average speed. Okay. So
Okay.
one is like the instantaneous speed. Okay. Ins instantaneous speed. Okay. And the other is like the average speed. Average speed. Okay. So instantaneous speed is basically the speed at a point where you are. Okay. Like
Mm,
it is referred to the specific speed at the specific time interval. Okay. This is a concept. Okay. So it is a speed, speed at specific position in time. Okay. Because it is instantaneous, so it is a specific speed in time. Okay. And the average speed is going to be the overall speed, like the overall speed, the average of all the different quantities, right? So it is basically defined as the total distance divided by uh over total time. Say irrespective of irrespective of what would be the speed at one instant, or what would be the speed at the other instant, right? Let's say the object is
okay.
traveling, let's say the object is traveling from, let's say, this point to that point, and in between the in between the journey, its speed changes. At, let's say, at this point, its speed was would be 10 ms minus 1. At that point would be, let's say, 12 ms minus 1. It would be at this point, let's say, 11 ms minus 1. Okay. So these are the speeds. Okay. And so these are the instantaneous speed, right? But if, let's say, the object takes the time of okay, so the object take this the object take 4 second 4 second to reach this point, and then it took let's say 15 second to get to that point. Okay. And it take around mm, okay, so it takes 4 second or 5 second to get to that point. Okay. And if I give you the distance, so the distance is, let's say, okay, wait. So for this one, the distance is, let's say, 40. Okay, 40 meters. And from the that point to the other point, okay, the distance is going to be uh, uh, um it will going to be, let's say, कितना होना चाहिए? 180. Right. And from the second cross to the third cross, the distance is, let's say, 55. Okay.
Okay.
So if you try to find out the average speed, so you have to add up the total distance, and you have to divide that by total time. Okay. So
Um, so 180 plus 40 plus
yes,
55, and then divided by, so 45 plus 15 plus 5. So it gives 4.2.
40 plus 180 plus 55 is 275, and
Yeah.
15, 20, 24, 24. So what you're getting? I'm getting
Uh, oh,
11.458.
wait.
It would be 11.5 then.
Hold on, maybe I did it wrong. Oh, okay. 11.45, yeah.
Okay. 11.45. Okay. So please keep in mind, acha, by the way, if you do 10 plus 11 plus 12, then you divide that by 3, you won't get the correct average speed. Okay. Please keep in mind. Okay.
Okay.
Okay. So if somebody wrote 10 plus 12 plus 11 divided by 3,
Oh,
okay, so it end up getting 11 and it is not a correct speed. Okay. It
so what did you wait? How did you get the 24?
I just add up time, 4 second, 15 second,
No.
and
Oh,
5 second. Okay.
okay. Okay.
Okay. So by the way, please keep in mind this type of average only useful in the data that is not related with the other formula, right? Like if you see the distance, the speed, so it is basically the distance upon time, right? So to find the average speed, you have to find or you have to add up the total distance, okay? And you have to add up the total time, okay? And then when you divide them, you'll get the total speed or the average speed, okay? If you just add up the speed and divide that by the number of the speed values you have given, so you end up getting the incorrect average speed, okay? Is that clear?
Yeah.
Perfect. Okay. So these are the two type of speed. And by the way, please keep in mind this formula, the speed is equals to distance upon time. It's only applicable when you have the constant speed, like when the object is moving with the constant speed. So the condition is okay only when the object is moving with constant speed. Okay. So in
Yeah.
that case, this formula works. Okay.
Okay.
Okay. If the speed changes, okay, then if the speed is changing, so they may ask you two things. Either they ask you to find the average speed. So for average speed, you have to find the total distance and you have to divide that by total time. Okay. This formula won't work. Okay. The average speed is basically the total distance divided by total time. Okay. This is a bit different formula, but actually the same thing. Okay. And the other thing that they can ask you to find the acceleration or anything regarded with the uniform acceleration motion. Okay. So in that cases where the object is accelerating, you are not allowed to use this formula. Okay. This won't work in those type of cases. Is that clear?
Okay.
Not clear or clear?
No, yeah, it's fine.
Perfect.
So only in the office moving constant speed. Okay.
Okay. So yeah. So these are the concept of the speed. Okay. Now I'm stopping the class right here. And inshallah
Okay.
we'll continue tomorrow and we'll complete these two things. I'll try to start tomorrow's class earlier, and I want to cover these things, okay, and then we'll see the rest inshallah after the week. Okay.
Okay.
Okay, so till then, take care. Allah Hafiz.
Okay. Allah Hafiz.
Allah Hafiz.